The fundamental laws that govern the universe speak to us only in the language of mathematics. The key to understanding this language is calculus. Calculus allows us to see the true beauty of nature. Calculus makes the predictions of modern physics possible. The variable y represents distance in space. The variable x represents moments in time. The purple line represents the relationship between space and time. This line shows what the distance in space is for every moment in time. Let us focus on what happens during just one unit of time. The distance traveled in one unit of time is what we call speed. The speed is represented by the green rectangles. Suppose we add the areas of all the rectangles together. The areas of all these rectangles add up to the distance traveled. Now let us consider a different scenario. Again, consider what happens during one unit of time. Again, the speed is the distance traveled in one unit of time. As before, let's add all the rectangles together. As before, the areas add up to the distance traveled. Up till now, we have only been dealing with cases where objects move without changing speed. Now let's consider a case where we change speed and sometimes move backwards. Again, the speed can be represented by a group of rectangles. This graph shows that the speed is no longer constant. Every moment in time now consists of a different speed. A negative speed is represented by yellow rectangles. A negative speed means that the object is moving backwards. Let us once again add the areas of all the rectangles together. The yellow rectangles have a negative area and cancel out the green rectangles. The area that is left once again represents the distance traveled. Let us change the graph for the speed of the object. Before, the graph of distance versus time consisted of sharp corners. Now the graph of time versus distance is much smoother. Now the graph is a smooth, continuous curve. Let us once again add all the rectangles together. No matter what kind of graph we have, the rectangles will always add up to the distance traveled. This is the fundamental theorem of calculus. Consider a very small increment of time, which we will call dx. Consider the distance traveled during this time, which we will call dy. The speed is the distance traveled divided by the time taken, which is dy divided by dx. We can therefore relabel the speed as dy divided by dx, and we refer to it as the derivative of y with respect to x. If we extend this white line, then dy divided by dx will be the line's slope. For every moment of time, dy divided by dx is the slope of the extended white line. As the slope increases, dy divided by dx increases. When the